Okay, everyone, so finally we go to the final point. The goal of today's lecture is we want to build a heap sort. We are making another sorting algorithm using the data structure of heap, right? So we are going to start from a random list of the numbers. They are unsorted, and then we want to first build a heap. So building a heap, we know it is a linear algorithm. So after we build a heap, what is the nice feature we know? What is the largest value? The largest value is on the very top, right? So at least by building this heap, we are already able to get the largest value. So now this is the interesting part. We want to do this. We want to put the largest value and then at the very bottom, at the very last value of the array. And then we are swapping those two values. So we are swapping the last value with the root value, also the largest value. We do a swap, and then after the largest value is on the tail of this heap, we are going to just discard that. We are no longer considering that value to be in the heap. So we move the largest value to the tail, and then we discard that. We don't want to touch it anymore, and then of course there's something wrong because the root value is now a small value, so we have to do a heapify. Okay, and after that we just repeatedly do this process, and eventually there is only one value in the heap. Okay, so let's see the code first. So when we are doing the heapify, if we want to do a sort of the array A, and then first we want to build a max heap, and after that, well, we are gonna do starting from the I as the length, and then we go down to 2. So I started from the length of the heap and then down to 2. And for each time, we are swapping the largest value, the root of the heap to the I, which is the tail or the end of the array, and then we do a swap, and then we want to decrease the heap size by 1. By decreasing the heap size by 1, we are excluding the tail value or the largest value from the rest of the operations. And after that, we do a heapify. We want to touch the root and put it at the right place, and then we want to do another process. Okay, and then we want to repeat the line 2. Okay, so let's see this example, and I have already copied that to my drawing board. So let's see my drawing board. So what's the first step? The first step is we want to build a heap, but in this case it is already a heap, so we have already done the build heap process. And after we have done the build heap process, what should be done next? We want to swap the 16 and 1. We want to put the largest value to the very end. So let me just do this. So we have the 16 here. So after we have the 16 at the tail of the heap, the next step is we want to simply kick the 16 out. Okay, and after that, is there something wrong? Okay, you will say, okay, this one, it can't really be at the top of this heap. So we want to fix that. So 14, 10, and 1. So 1 will swap with 14. So I will do a 4 here, and then I get rid of this 4. So are we correct? No, this 1 should be swapped with the 8. So 1 and 8. There should be a swap. So 8 goes here, 1 goes here. And this 1 is still not correct. So I want to erase this 1 and swap with this 4. So 4 and 1. So okay, we have done one swap between the head and the tail, and after that we kick the 16 out, and we have done one heapify. So we exclude this 16 out, and after that, I don't want to zoom in that much. Okay, so after this 16 is kicked out, and then we have done the heapify, so we still have a valid heap, and then this 16 just stayed here. Okay, 16 is already detached. So what's the next step? So for the next step, we want to swap the 14 with the 1. So we want to swap this 14 and this 1. So 14 goes here. And after that, 14 will be detached. Okay? And you will see, okay, this 1 is not at the right place, so we have to shift this 1 down. So 1 will be shifted with 10. And then when 1 is here, 1 is still not correct. So 1 will be shift or swap with 9. So 1 and 9, another swap. So 9 goes here, 1 goes here, and then okay, that's another swap. It's the largest value to the tail, and then another heapify. So we have excluded 14 and 16. So what's the next step? We want to swap 10 and 2. So 10 and 2, there will be a swap, and then 2 goes here, 10 goes here. And after that, this 10 will be detached from this heap. And 2 is not at the right place. We want to do a heapify. So 2 with 9. So 9 and 2. And then 2 is not correct. So we want to swap 2 with 3. So 3 and 2. Okay, so heapify done. Other than those 3 values, we still have a valid heap. And then if you want to do another level, you want to swap 9 with 2. Okay, so 2 goes here, 9 goes here, and then 9 will be detached from this structure. And then we want to fix the 2, so we want to swap the 2 and 8, because this is the heapify process, and 8 and 2, and then 2 and 7, another swap. So here we have 7 and 2. Okay, so we have the 9 detached, and next round we are going to swap 1 and 8, and then we are going to detach the 8. Okay, by the way, if you have already seen how this process, then feel free to skip this process. Okay, so 1 goes here, and then okay, this 8 is detached. We want to fix the heap again. We want to do a heapify for 1. So 1 and 7, and then 7 should go up here, and then 1 is here, and then 1 and 4, another swap. So I want to get rid of this one, should be a 4, and then 1 goes here. So well, 8, 9, 10, 14, and 16, they are all detached. And how about this 7? This 7 will be swapped with 2. So 2 will go up, 7 goes down, 7 goes down, 2 go up, and then this 7 will be detached from the heap structure, and then we want to fix this 2. So 2 and 4, there will be 1 swap. So 4 and 2. Okay, so it is still a heap if we exclude all the orphan nodes. Okay, and the next part, we want to swap the 4 with the 1, and we will have 1 here and 4 here, and then 4 will be detached. Okay, and now another heapify, even though we only have 3 nodes, and we want to heapify, and then we want to swap the 1 and 3. So after we have the 1 and 3 swapped, now we have a valid heap. And after that, another round of the Heapsort. So we swap 1 and 3. So 1 go up, 3 go down, and 3 will be detached from this heap structure. And now we only have 1 and 2. And for 1 and 2, unfortunately, we have to do this again. So, well, 1 and 2 will do, and then, wait, I have to fix the heap first. Sorry. So, 2 and 1. And then, okay, this heap is fixed, only 2 nodes. And after that, another round, we want to swap the largest value to the bottom. So, 2 and 1. 2 here, 1 here, and then we detach. So if there is only one value, which is this value in the heap, and then there's no need to do the heapify because this is the only value in the heap. Okay, but now what do we have? Well, if we remember, those values are still in a list, right? So in the list, what values do we have? We have, at the beginning, we have 1, and then 2, 3, 4, 7, 8, 9, 10, 14, and 16, right? So, well, if we just grab all the values still in this array, what do you have? You have a sorted list from low to high. Okay, so this is the heap sort process. Okay, and let's go back to our lecture notes. And well, before we finish today's lecture and the analysis of the heap sort. Okay, so how do we do the heap sort? Number one, we want to do a build heap, and the build heap is a ON algorithm, right? And then how many heapifies we have to do? Well, we are going to do the length down to 2. So n minus 1 total heapifies. So n minus 1, and then for the heapify, that is a O log n algorithm. So a O n and plus a O n log n, so this will give you a O n log n algorithm. So for the heap sort, that is a O n log n algorithm. And that's the end of this lecture. Okay, so that's all, and I will see you in the next class. Bye bye.